Swayam Prabha. Digital India. Educated India.
Good morning, gentlemen. So let's continue our discussion on this one-dimensional problem and then how to develop the finite element equations. So we have taken this one-dimensional with three subdomains or three elements and the four nodes 1, 2, 3, 4, x1, x2, x3. So this is what we have been doing in the last class. So for taking the weighting function as ni, and then the weak form looks like this one, and here we are taking the weighting function as n2, and n2 and n3 are the only possible weighting functions for this problem, where the end function values phi1 is equal to phi a and phi4 is equal to phi b have been prescribed. So if those are the things which have been prescribed, then the condition on the weighting function is that it has to be 0 at those points, at the end points. So that is only possible by n2 and n3. So in this particular case, we are looking at taking wi is equal to n2. So this is dn2 by dx and so on. And here we have phi1, phi2. This is for the x1 to x2, and then we also have, we do this. In fact, we have the two more terms that need to be added here. I think there is some things, I think this is a little incomplete. And so on. By 3 and one more term here. So similarly here we have another two terms. Okay, so this is what it is. I think I should better put it in a slightly concise manner. Let me do that. So the equations are pretty long, and sometimes we get lost in that. So we should be, this is a very important step and we should be very careful in knowing this. So wi is equal to n2, and let me write it. So the weak form a little repetition, of course. Let me be complete because I'm just continuing from this point. So let me have this step again. And where phi hat, of course, is known as phi1 and 1. Here phi1 and phi4 have been prescribed to be phi a and phi b, and that's what we do. So when we write this one here, so the above statement will look like x1 to x4 once we get used to this, then I'm going to simplify this further. So this is equal to 0. And here we can combine these things as like this one, K2151, K2252, simplifying. So this is what we have. So where K21, K22 and so on. So here the combining the one which is before 51 here, dn2 by dx, dn1 by dx, as well as n2 and 1. So here this K21 is this one, or for that matter we can even write Kij as dni by dx, dnj by dx, this is for the whole domain. This is what Kij in general is. That's what you can infer from here. This is what we were doing for a very generalized element. Okay, here this Kij is all the way from x1 to x4. And so if you want it, so this Kij should be split up into x1 to x2 and x2 to x3. Same thing, x3 to okay. The same thing you can write it here. And then in which case, so this is 1 and this is the domain 1, this is domain 2 and domain 3. Then the n1 or ni, nj, whatever have to be taken appropriately for this domain. Okay. So what we have done here is that a Kij has been, we have done it for a very generalized element, and this Kij we found it in the morning. We put it here. So if you want Kij, so this is, you can even say that this is Kij for element 1. This is Kij for element 2, element 3. And Kij, as we did in the morning, for any element E, so Kij is a very general term. So Kij has 4 terms. So depending upon whether you take Ii, Ij or Ji, Jj. So that's what was done in the earlier class. So in fact this we can, if you think that this is H, so we can simply put it like in the matrix form as 1 by H, H by 3 for this element, minus 1 by H plus H by 6 This is for h being the size of the element. In fact, h can be different for different elements. It's not necessary that it has to be same for all the elements. So this is what a general element looks like. This one here, or Kij, where I and j and I and j are non-zero there. So if you look here, this is now this is given in general. So now let's look at K21, for example. Let's look at K21 here for this one, and which is a sum of 3 zones here, right? And so here K21 in the domain 1, K21 coming from domain 2, K21 coming from domain 3. If you look at this here in a nutshell, maybe I'll just, this is too small here, let me just draw it here. One, 2, 3, 4. This is N1. This is N2. N2 has element 1, element 2, different representations. And similarly here, so now if you look at this one, so can we do this one knowing this thing? Each, let's assume that all h are same. So this K21 means what? So it has N2 and N1 in this one from element 1. So if you look at this N2 and N1, so this is N2 and this is N1 here, and this is N2 and this is N1 in domain 1, in element 1. So that is the contribution. So how much is this? So if you look at this one, so this is coming from Ni and Nj. So if you do that, it's 1 by h plus h by 6, right? So this is okay. So K21 coming from element 2. So if you look at K21, which is having the functions N2 and N1, and coming from N2 and N1, coming from, this is N2 and this is N1 coming from element 2. So if you look at the element 2, now N2 is non-zero, but there is no N1 here. So this contribution is 0. And similarly, K21 coming from the third element is that in the third element, both are 0. Okay. So this is how K21 we can find out very quickly by having a general element contribution here like this one, right? So this is K21. So can we find out K22? So K22 has, so if you look at K22 of overall thing is a contribution from element 1, element 2 and element 3. So look at, everything is only 2 and 2. Both weighting function is N2 as well as the trial function there for that phi 2 is N2 itself. So if you look at N2, okay, N2 in element 1. So obviously it is there in element 1 and multiplied with N2 itself. So what is that contribution then? So if you look at this one, so both are there like this one. So it is nj. So that's what 1 by h. So this is 1 by h plus h by 3. Okay, so this is for this part. And then 2 also has contribution from element 2. So exactly the same thing as this one. And what about 2 coming from element 3? So N2 is not there at all in the element 3. So it is 0. Okay, so like this we can do K23. So K23 coming from element 1, K23 element coming from element 2, K23 coming from element 3. So this involves the N2 and N3 from element 1. So what do you think of element 1 of 2 and 3? So in element 1, N2 is non-zero, but there is no N3, right? So this first contribution is 0. And K23 coming from the element 2. So if you look at K23 coming from element 2, so this is element 2. So we have N2 as well as N3 like this one. So that means that it's equal to Nij combination cross product. So it's minus 1 by h plus h by 6. And K23 coming from element 3, okay, which is N2 and N3. So N2 is 0, though N3 is non-zero. So the product is 0. Okay, so this is 2, 3. So similarly, we can go like this, K24. So K24 comes from element 1, element 2, and element 3. Okay. So what is this then? K24, N2 and N4, you have to look for in the elementary element 1. So if you look for this is N2 and N4, right? In element 1, it is 0. In element 2, this is 0. In element 3, this is 0. So all 3 contributions, either this is N4 is 0, this is N4 is 0, and this is because N2 is 0. So this is K24 is completely 0. Okay. So now this equation is complete. So if you want to write down this equation, so this equation is the complete equation so we have K21, okay. K21 is how much? It is, we calculated that, so that's equal to K21, it's 2.94, it is minus 2.9451, and K22 is combination of this one, so it is 3.11 plus 3.11, so this is 5.2, and 2.3, this one is minus 2.94, by 3, and then this is 0 times by 4. So you can neglect this one. Okay, the last one, there is nothing K24. Okay, so like this, the third, the one more equation. So taking one more equation, taking Wi is equal to N3, right? So this is the other equation which we need to get. So I'll just put it here. So this is K3151 K32, phi 2, and K33, phi 3, K34, phi 4. Of course, this phi 1 and phi 4 are prescribed as phi A and phi B. So now this equation also we can very easily form. So K31 is because of element 1, because of element 2, plus because of element 3. So what are these things? Then K31, so 3 and 1, right, to start with. So this is 3 and 1, right? So this has, in the element 1, N1 is there, but N3 is not there. Okay, in the element 2, N1 is 0, but N3 is there. Here, N1 is 0, though N3 is 0. So one of it is 0, so it is essentially 0, like this. Okay, so similarly K32 here is K32 coming from element 1, element 2, okay, so this is how 3-2. So if you look at 3-2, so it's coming from a combination of N3 and N2, right? N3 and N2. So here element 1, it is 0, right? This is 0. Element 2, you have N3 and N2 are non-zero. So that contribution would come. So it is minus 1 by H plus H by 6. Okay, so this is 3-2 and 3-2 and K32 coming from element 3. So this is 3 and 2 coming from element 3. So this is 0. So this is non-zero, though it may be. So it is 0. Right? So like this you have 3-3 from element 1, element 2. Okay, so how much is that? 3-3. Obviously it is both 3, so there is nothing in element 1, so it is coming from element 2, so which is 1 by H plus H by 3, and the same thing from element 3 also you have exactly the same contribution. Okay, so same thing, let's continue here. K34 is K34 element 1, K34 element 2, K34 element 3. So we are looking at the combination of 3 and 4, right? 3 and 4. So there's nothing here, nothing here. Element 1, element 2, they're both contributions. N4 is 0. And only in the element 3, it is non-zero. And how much is that? N4, N3 and N4 here, right? N3 and N4 here. So this will be how much? So opposite sides, minus 1 by H plus H by 6. Okay, so like this we have the equation taking Wi is equal to N3. So essentially, so the complete equation will be, so 3-1 is 0, so there is nothing, 5-1, I'll put 0, 3-1 is 0, and 3-2 is minus 1 by H plus H by 6, that's 5-2, and 3-3 is 1 by H plus H by 3, and again same thing, This is phi 3. And for phi 4, we have phi 3, 4 here. And we have minus 1 by h by 6. Okay, so the complete equation looks like this one. Right? So this is their two equations. Now let us, so if you concisely put them here, so let us putting the numerical values. So we have 2.9451 plus 6.2252 minus 2.9453 is equal to 0. So this is the equations. So equations are and the other equation now here is 6.2252 minus 2.9453 and minus 2.9454. So these are the two equations. So if phi 1 and phi 4 are given to us, okay, as phi a, phi b, so in fact we can even combine them in the matrix form. Phi 2 and phi 3, and we can take this. So this is known and this is known, so let us take them to right side. Phi a, maybe I can put it phi a. Okay, so phi 1 and phi 2 or phi a and phi b, as we did for starting with. Okay, so this is the equation. So as an example, taking phi a is 1 and phi b is 1. So we get the solution phi 2 and phi 3 as 0.8963. Of course, simple problem, but they're same. Okay, so that means that finally, what is the solution then? I'll just draw it here. The final solution, this is 0 and 1. So what we have here is full phi hat. So you start up with 1 that has been given, and it goes a little low, and let so this is equal to 1.894.8. Okay, so this is a very simple complete solution. Okay, so I hope you got the complete picture. It looks like there are too many terms to evaluate, and then there are too many integrals that need to be evaluated. No, it's not. It's in fact, if you look at these things a little bit carefully, so there are many zeros are there. Many zeros are there. And so you need not really evaluate all those zeros. Only thing is that you should know which are zeros and which are non-zeros. So that's what we are going to see in our next lecture. So we'll stop it at this moment, and then we'll continue this one. We'll see how this can be further simplified. So for the moment, it's bye-bye.